at polynomial factorization. We're going to look at the unit test here on Khan Academy for polynomial factorization, and kind of create a study guide of sorts, a video study guide of sorts for you to help you out to get ready for the summative assessments you're going to get at the end of this week. So let's take a look at this. There's a few questions on here that won't actually come up in the summative, but we'll cover them anyway. So let's take a look at what we've got. We're looking at factorizing here. We're looking to factor this following expression here, this expression 9x to the fourth minus 6x squared y to the fourth plus y to the eighth power. You'll see it's quite a complex, it looks like quite a complex equation. It's essentially just a quadratic though. Take a close look at what we've got here, right? Notice how the 9 is itself a square. X to the fourth is just a square, is just x squared squared, right? You've got y to the eighth is y to the fourth squared, right? And then right here in the middle, see that square that I just talked about, and that y to the fourth square that you see here on the right hand side, and then you've got 6, which is basically 3 plus 3, so it's 3 times 2. So we're kind of expecting this whole idea of where we're going to get where we have a first term. They're calling them u and v here. If you think about u minus v, and they're pointing out here we can factor this expression as u minus v. And if we look at this idea of u minus v squared being u minus v times u minus v, hopefully we can actually see that we can FOIL this out, and it'll work out as being u squared minus 2uv plus v squared. All right, so that's kind of what we're going to get from there, and it looks similar here. We've got u squared minus 2uv plus v squared, and so all we need to determine is what are u and v in this situation. Okay, so all we got to do is take the positive square root of this, the primary square root of this, and we're going to get u. So the square root of 9 is 3, the positive square root of 9. So we're going to u is equal to 3, and x to the power 4, right, the square root of that is x squared, so x squared. So we know that if we were to square this 3x squared, right, we're going to get 9x to the 4. And then all we need to do is look at the opposite side here, right? Look at y to the 8th, and we're going to get v. So the square root of v is going to be y to the 4th power, right? So let's try that out. Let's prove it. We're going to choose an answer down here, and we're going to see that our answer here is this one right here, but we're actually going to prove it as well. So if we were to take 3x squared minus y to the 4th, and if we were to square that, okay, so this is what we're claiming, is that these are our two u and v terms, so that's going to be equal to 3x squared minus y to the 4th times 3x squared minus y to the 4th, right? So this is so let's FOIL this out. So 3x squared times 3x squared is equal to 9x to the 4th power. Right, this is looking positive here, right? 3x squared times negative y to the 4th is minus 3x squared y to the 4th, and 3x squared times negative y to the 4th is another minus 3x squared y to the 4th, and then negative y to the 4th times negative y to the 4th is positive y to the 8th power. So we're adding the exponents there. So we combine like terms in the middle, and we get ourselves 9x to the 4th minus 6x squared y to the 4th plus y to the 8th. Okay, so we can see how we can use this kind of u minus v method to factor these, factor this. Now there's a second part to this question here that is asking us to factor the expression, so all our work is not in vain. It's right there for us. So how do we factor this expression? Well, it's perfectly okay just to put it in as the u minus v all squared factor. So here we go. So 3x squared minus y to the 4th and all of that squared. So this is, go out here, and all of that squared. Here we go. So we're looking at this is our factored expression. This we just proved it. Okay. So once again, a little bit of practice in factoring completely. We're seeing something similar here. Now we looked before at the u minus v squared situation. Okay. There's three kind of scenarios with essentially with quadratics. Okay, and one of those scenarios is the difference of squares. So we've got our essentially what is our u minus v times u plus v, and we know that this works because what happens is when we multiply the u times v here, the u times positive v here, and the u times negative v here, they tend to cancel each other out, so we end up with nothing in the middle. Okay, and we always will see a negative in the middle here because we've got opposite signs. So we've got a we've got a negative v times a positive v, giving us a negative in the back. So we can actually look at the square roots of both of these terms as being our u and our v. So let's take a look at this. So u is going to be equal to, well, the square root of 4 is 2, and the square root of p is just p, and v is going to be equal to, the square root of 25 is 5, and the square root of q is simply q. Okay, so let's test this out. Okay, we're being asked to factor it completely anyway. Okay, so we're looking here, therefore, at 2p minus 5q, minus 5q, and 2p plus 5q. So this is what we're claiming to be our factors, okay? So let's FOIL that out to prove it. Okay, 2p times 2p is 4p squared. 2p times positive 5q is 10pq. 2p times negative q is negative 10pq, so they cancel out, right? So I'll just write them out so you see it. So plus 10pq and minus 10pq. Right? And then we've got negative times positive, so it's a negative 25q squared. As we can see, these two cancel out, and we're left with what we were expecting to get. All right, so we're just putting in the factors for this here. So we're putting in our u minus v, u plus v. So 2p minus 5q and 2p plus 5q is what we're looking at here. Okay, so okay, the next example here is, this is actually, this is polynomial identities, and it's not something we really assess in our assessment, but the general idea here is asking like whether these are actually equal. So you got two polynomials here, and are they identical, right? That's really the question here. So essentially, are these in some way factors of these ones here? So this is a kind of a nice question because it's going through the steps for us. All we need to do is we need to look at one side and see if we can match it up with the other side. So we perform some simple algebraic equations on it and see if algebraic manipulation on it and see if it actually works, right? So we're starting with this left-hand side here. We're looking to try to get the right-hand side. So the first part here, what he's done with step 1 is, you can see there's a FOIL going on here. So 9x squared, that works, right? So 9x squared, and then multiplying in x times 3. So that's 3x. I'm just gonna put that 3x there as a placeholder for now. We can see that something's going on here, right? And then you've got a plus 3x. So there you go. That's that's the plus 3x. So this is 9x squared plus 3x. So you got the plus 3x, and then he's distributing this in as 3 times 3 is 9, so plus 9. So this is indeed identical to the first line. Okay. So the next thing here is he's recognizing essentially a u plus v squared pattern, right? So we're looking at this u plus v squared pattern. Okay, so the idea being that the first term, if we take the square root of it, so we should have a 3 x, right? We're just taking the square root of 9 and the square root of x squared. Okay, and the last term, we're taking the square root of that, so that's 3. And what we're recognizing there is what happens when we got a u plus v squared, right, is what that does is it doubles the middle. Okay, so watch what happens with that. So we've got, it should double the middle. Okay. But I'm not entirely sure that's correct. So let's take a look. U plus v. So this is what happens here, right? Just I want to show you what happens because we showed other examples here. So you see our u squared, that gives us u squared plus 2uv, that's the uv here and the uv there, and then plus v squared, right? So that's kind of what we're expecting to get. So we're expecting this 6x to be a double of uv, right? So we're claiming that this here, this is what we're looking at as our u plus v. Is this actually true? Okay, so is 3x, is it true that if we were to take 3x times 3 and then double it, is it equal to 6x? So we get 3x times 3, that's equal to 9x, which if we multiply a 9x times 2 is equal to 18x, right? So we're actually expecting 18x here in the middle. So I can see there's actually a problem right here in step 1. There's a problem with saying, not in step 1 here, this is correct, right? This part here is correct. There's a problem in saying that it is a u plus v pattern. So step 2 is actually the problem, not step 1. So this is where the mistake is. So essentially the idea is, if it were true, if it was actually to come down to the very bottom, and if it were actually true, then we would have an identity. With this kind of problem, we don't. I won't go into too deeply because it doesn't come up in the assessment. But if you're curious, you can find out more. So he made a mistake on step 2 in there, and we move on from there. Okay. Right, greatest common factors. These are a little bit simpler here at this point. So greatest common factors. The first thing we do is we take the coefficients. So what are the factors of the coefficients? So 54. We've got factors of 54 is factors of 54. Well, let's start with the prime factors. So we've got 2 times 27, and then with 27 we've got 3 times 9. We've got 3 times 3. Okay, so there's our 54. Okay, for 18, we've got 2 times 9, and then we've got 3 times 3. Nice. And then we've got for 36, well, actually, that's just an extra extension of 18. We've got 2 times 18, and then 2 times 9, and then 3 times 3. Okay, so we've got quite a few common factors here. Let's work our way backwards. So we've got 3. I'm going to change color here. We've got a 3 here. We've got a 3 and 3. We've got another 3, 3 and 3. And we've got a 2, 2 and 2 and nothing else. Right? So we've got 2 times 3 times 3, which is 18. So 18 is our common factor here. Right? So 18 is our common factor for the coefficient. Now we look at our variable. What is the lowest exponent in our variable? There's just z to the first power. So 18z is our greatest common factor here. So we can use 18z to factor out of those 3 if we need to. Okay, so here's a kind of error checks, I suppose, right? So Sophia factored 81y to the 6th as 9y to the 3rd times 9y squared. We can see that that is correct because 9 times 9 is 81. Y to the 3rd times y squared is indeed is not y to the 6th. That is not correct. This one here, what she's actually got here is we see it's 81 because you add the exponents. It's 81y to the 5th. So we've got an error here, and I presume that's going That's going to be the question, right? Ahmed factored it as 3y to the 6 times 27y. Okay, so well, 3 times 27 is indeed 81. However, y to the 6 times y is y to the 7th. So we've got an error there as well. So neither of them have factored this correctly. Okay, so perhaps factoring this correctly, if we were to actually say so, would be to say that it could be factored, and I mean, there's many ways of factoring 81, but let's go with the 9 times 9. We could say 9y to the 3rd power, say, times 9y to the 3rd power. All right, so anything along those lines. You could even go with the 3y to the 4th power times 27y to the 2nd power, so that your exponents need to add up to 6. Okay, so there you go. All right, next example here, we want to actually factor the expression here, and we see our patterns showing up again, right? So remember, there's 3 patterns there. There's and well, 2 of them are similar. We've got our u plus v pattern, right? U plus v squared. We've got our u minus v pattern squared, and we've got our u plus v, u minus v pattern. Okay. Now, what we find is characteristics of these patterns, right? And characteristics of these patterns are that with this first one, u plus v squared, we're going to get u squared plus 2uv plus v squared. With the second one, we're going to get u squared minus 2uv plus v squared, right? And with the third one, it's a difference of squares. We're going to get u squared minus v squared, right? That's how what happens is the u times v, u times negative v and the u times positive v cancel out in the middle, but because they're different signs, the v and the negative v will multiply together, make a negative v squared. Okay, we've got an issue here because this is actually a positive, right? So we've got a problem. So none of these will actually work, okay, because it's a positive. Right? If this were a negative, then we would be going with the difference of squares. But because it's a positive, we can just skip everything here, and we can recognize this is not something we can factor in this way. Okay. There are, of course, other ways of factoring it, but we don't actually go into it right now. All right. So the next one here, factoring this completely, right? So factoring this one completely here, we're going to find our greatest common factors first, right? So pull out your greatest common factors. So 7, 21, and 14. Looks like that's going to be a 7. So we've got a 7. X to the power of 3 is the greatest common factor here, and that's going to give us x squared minus 3x plus 2, right? So the first thing what we see there is by pulling out the greatest common factor and dividing it out of each term, we now see we have ourselves a quadratic here, which is really nice, okay? So now we can work on second step here by getting the factors of the quadratic, and it's a simple quadratic with a leading coefficient of 1, so that's quite easy to, all we got to do is find the factors of 2 that add up to negative 3. So the factors of 2, they're adding up to negative 3, they're both going to be either both positive or both negative. They've got to be both negative because our middle term is negative, so we're looking at 2 and 1, so negative 2 and negative 1. Negative 2 plus negative 1 is negative 3, so that works for us, and so negative 2 and negative 1 will work for us. And don't forget, we have a 7x cubed on the outside, and that's it. We're good with that. So, And there you go with that. Okay, two more questions, and we're encountering right now, we're encountering a, I think you could probably even stop the video at this point if you don't want to go any further, because I think the last two questions are going to be on geometric series. It's an interesting thing to look at, but it's not going to come up on our test. I'm going to complete the video by doing them just so that we have it, because I want to show you the end of the video as well. So I'm going to do this and show you how geometric series works. There's a formula that goes along with it. So the series, so the sum of the first n terms of a geometric series is equal to the initial amount, right? The initial amount times 1 minus the rate of change, so the percentage, I suppose, right? The rate of change to the power of whatever the term is, right? Divided by 1 minus that rate, okay? So this is our formula for calculating it, okay? And if you want to learn more about how that actually works, there's plenty of resources in Khan Academy on that for that. Okay, so this is our formula, this is how it works. So basically, if we're looking at this 35,000 a year in the first year, and each year he gets a 3% raise, what we're looking at here is that he started off with 35,000. Okay, so we're talking about the first n years of the career of his career. So we're saying the sum, the total amount that he actually earns, the sum in the first n years of his career, is going to be equal to the 35,000, right? 35,000 times 1 minus, and this is our percentage, right? So we're looking at 1.03 to the n, and you'll see your negative 0.03 here. Okay, so 1 minus this rate 1.03. When you subtract 1.03 from 1, that's what you're going to get here. So we're looking at this first option right here. Okay, the last one. This is actually another factoring one that we'll see in the last one here, and we see we've been given an area, and we're being told the width of the rectangle is equal to the greatest common factor. So first we've got to take the greatest common factor here, right? So our greatest common factor of 12 and 21. So we've got 2 times 6 and 2 times 3. And then 21 is 3 times 7, so our common factors are 3, okay, and y squared. So our width is 3y squared, okay. So when we factor out 3y squared from 12y squared, we simply get 4, okay. And when we factor out 3y squared from 21y to the 5th, we get 7y to the 3rd power. Okay, so that's how that one works there. So we can our width is quite straightforward. Our width is just 3y squared, but our length is a polynomial, of course. So it's 4 plus 7y to the 3rd. And there we have that unit test. So once again, just to illustrate what happens when you finish a unit test, is it gives you a report right here. It gives you your proficiency on them. You can see that some of those are the first time we actually tried them, so you see they actually only go up once. But once again, you can actually go back into your report here and you can see, all right, which are the ones that I was good with, right? So you can see there, some of them are only on 1 bar. Maybe there's some recommended practice for you there. And you go from there. All right. So if you have any questions or comments, please leave them below, and I will be sure to get back to you.